part of the collaborative project, we have developed an innovative method for designing multi-stage forging technology of nanobinding steel using integrated methods of numerical modeling, dynamic material modeling, and microstructure evolution modeling. The processing maps developed through dynamic material modeling are foundation of our work. In the case of processes that are short or occur under isothermal conditions, they are essential. However, the challenge lies in maintaining the formation parameters in the context of changing material temperatures during multi-stage forging. The key innovation of the project was the integration of data from the dynamic material modeling with hot forging simulation using finite element method. This advanced integration allows us to obtain detailed results at each stage of forging process. The DMM calculation are input into FEM program allows us to perform a significantly more precise analysis than standard methods, predicting more accurately the location of zones sensitive to formation of defects. Then we developed microstructure evolution models that depend on forging parameters. This comprehensive data allows us to predict which phenomena are responsible for microstructure evolution at each stage of forging, determine the final grain size, and optimize successive process steps. Verification of obtained results involved hot forging tests on a model nanobinding steel forging. To carry out these tests, toolsets were designed based on integrated analysis. The forging parameters developed through integrated DMM modeling and FEM simulations were applied, confirming the validity of the innovation. This integrated approach is innovative and represents a significant step towards the revolution in the metallurgical industry. It allows to precise process design, quality control, and production optimization, which is crucial for the future of this industry. This solution can be used as a basis for a building of the controller that allows for precise, real-time control of the forging process. Such application of this innovation is currently the subject of the research by our team.